Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to the Reliability Matters podcast. I'm so glad you're with me today. This is episode number 97, and as I said in our previous episode, we're getting very close to episode number 100, only 3 episodes away. For our 100th episode, we're going to do something we've never done before. Our 100th episode will be live. It will be live streamed on LinkedIn and on YouTube on July 26 at 10 a.m. Pacific time. We'll replay clips from several of our prior episodes and hear a few comments from some of our past guests. As we creep ever so close to episode 100, once again, I'd like to thank both my guests and you, the listeners and viewers of this podcast, because as I said the last time, without you, I would just be another talking head. And Lord knows we have plenty of those these days. If you're watching this on YouTube, click on the subscribe button and click the bell icon to be notified when new episodes are released, including our 100th episode. If you want to watch our 100th episode on LinkedIn, just follow me on LinkedIn. If you're watching this on YouTube, the link for my LinkedIn link is right down below. Just click on the Show More button. And if you're listening to this podcast on your favorite podcast app, just click on the show notes for my LinkedIn link as well as the link to YouTube. Today's topic is a little different than most topics on this show. Today, we're going to talk about best practices in a different context. We talk frequently about best practices when it comes to production techniques. Today, we're going to talk about purchasing best practices. The key to reliability is often the selection of suitable equipment for a specific purpose. Even if our intentions are good, if we purchase the wrong product for a specific application, that could actually contribute to a reduction of reliability, not to mention a waste of time, money, and resources. Today, we're going to talk about purchasing and equipment selection best practices as it pertains to X-ray inspection equipment. Inspection is vital to avoid escapes, that's to say, allowing defective products to leave your factory. While our primary goal is to avoid defects altogether, if there is a defect, it's best to find it while the board is still on the factory floor, before it's shipped to the end user. I put together a panel of 4 X-ray experts, 2 consultants well-versed in X-ray technology, 1 manufacturer of X-ray equipment, and 1 end user of X-ray equipment. Each brings a unique perspective to X-ray technology. Rather than reading 4 individual bios and taking up a valuable time on the show, I'll bring my guests in and have them introduce themselves and provide a little bit of background on their experience within the X-ray industry. Well, welcome everybody. I'm really glad you're with me today. You may notice that we talked about 4 guests, and right now there's 3. Keith Bryant is having a little bit of technical trouble right now. He's trying to work that out. So we'll welcome Keith into the family here once his internet troubles are worked out. Perhaps the basis of his trouble was his computer wasn't properly X-rayed. I don't know. Let's make that reach. Before we dive into the material, I'd like to just kind of go around the screen here. Let's start at the top. Dr. David Bernard, go ahead and introduce yourself and give us a little bit of your background.
Well, hi, Mike. Thanks for the invitation to participate in this latest edition of the Reliability Matters podcast. It's fantastic. You're almost at your 100th episode. And I also feel very fortunate that you were kind enough to ask me to be your guest on the 10th episode, and yet you still asked me back. Anyway, I'll leave that to your listeners. My name's David Bernard, and I've over 20 years' experience in the use of X-rays for the inspection of electronic components and circuit boards. And for the last 5 years, I've been an independent X-ray consultant for the electronics industry, helping X-ray suppliers and users to optimize their opportunities for using X-ray inspection.
Excellent. That was David number 1, and now we have David number 2. Welcome to Reliability Matters, David.
Yeah, thanks for having me on, Mike. Big fan of your show. This is pretty awesome.
And I should say, I'm a fan of the work you do too. You also
thank you.
produce video episodes. I'm not sure if technically it's a podcast, maybe it is, but it plays like one. And I've been a guest on your show, so it's the Mutual Admiration
Yeah.
Society.
Yeah, definitely. For your listeners who don't know me, I'm the sales manager at Creative Electron. Been here just about 4 years. Prior to that, I've been working in the electronic manufacturing industry for another 7 prior to that. So been around this industry for a while now, not quite the experience that we have here in the room, but very happy to be here and able to learn from you guys some more.
Excellent, and we're glad to have you here too. And it looks like if we play our cards right, it looks like we have Keith back. Let's switch over to Keith before we lose him again. Go ahead and introduce yourself. Tell me a little bit about your background.
Hi, Keith Brown. 30 years in our wonderful industry in various positions, including a couple of spells with major X-ray companies. Been working for a while as a technology and business consultant with a specialist subject in X-ray. So hopefully I know a little about what we're going to talk about today.
Right, and you were with an X-ray equipment supplier for several years. So you've represented them, you've sold them, you've consulted with X-ray suppliers as well. Is that correct?
Yes, two companies, in fact, as an employee and about 4 as a consultant.
Right. And I have witnessed some of your presentations. I have to say the X-ray industry has the coolest slides because you get to see through things, and no other. I do a lot of cleaning presentations. Cleaning can never be as cool as X-ray. We just don't have as compelling of images as you guys do. I've always been envious of your ability to present very compelling images in your presentations. Rob, welcome to Reliability Matters. I'm glad you're with me today. Now, you don't sell X-ray equipment. You are on the other end of that spectrum. Tell me about the company you have and your relationship with X-ray equipment.
Thanks, Mike. Thanks for inviting me. And like David Bernard, this is my second appearance on Reliability Matters. I think I was one of your first guests in the summer of 2019. So here we are, almost 100 episodes. That's tremendous. I am the president of a company in Fremont, California called Daytest. We are a test engineering and failure analysis company. And in the failure analysis aspect of our business, we operate multiple X-ray and CT scanning systems for inspection and detection and root cause analysis purposes. I too am a gray beard in the industry. I've been doing this in one form or another for 47 years, first in PCB fabrication, followed by contract manufacturing, and since 2009 in test engineering and failure analysis. So if nothing else, I've accumulated a lot of stories along the way that hopefully will help us today in explaining to folks making good decisions about equipment. Yeah,
excellent. So before we get into kind of the Q&A portion of this, I want to just talk about my perception of X-ray equipment in general. Like many products within our industry, X-ray equipment comes in all shapes, sizes, capabilities, and price ranges. There's a plethora of brands and capabilities and applications and things like that. And with so many manufacturers, each with multiple models, and I think the possibility to under or oversell equipment is measurable, particularly with wide price ranges. People tend to want to pay the least and get the most, and that's not always possible. Let's start at the beginning, though. X-ray's been around for well over 100 years. If you're not in the electronics industry or any industry that uses imaging technology, then probably your only experience with X-ray is at the dentist or in a imaging lab at a hospital. Maybe you broke your leg or cracked a tooth, whatever. It's more than likely you don't have a lot of experience with the technology of X-ray and maybe all of its intended and unintended applications within our industry. So give me just a general overview of how X-ray technology is used in the electronic assembly industry. Just give me some of the typical applications and benefits that technology provides, maybe some of the unique benefits that technology in general provides. Anyone who wants to start can go ahead and start, and then we'll just kind of
Did you want me
bounce around
to
the
have a
table.
go first?
Absolutely.
Let me have
ahead.
a go first, and you can see if you agree or disagree, fellow
Okay.
panelists. In terms of the application, it's exactly the same as hospitals. You want to be able to non-destructively test what you're looking at without, like in a hospital, having to saw the leg off somebody to see if the leg is broken. The X-ray allows you to do it non-destructively. And in the electronics industry, the non-destructive applications are looking for things when components go on boards. And in particular, you're trying to look at things that you can't see optically. The traditional, most common example and the reason for justifying X-ray inspection in electronics was the BGA, the Baldwin array. And these days it'll be the bottom termination components, QFNs, LGAs, and things like that. So non-destructive, seeing things you can't see optically and trying to spot things that go wrong, not that they ever do if you speak to any people who are buying X-ray equipment, but assuming they might do, you can spot it early and fix it before it goes to your customer.
Excellent. Any other input?
I would just add that X-ray applications in our industry went from being a novelty to a necessity with the advent of surface mounting. Prior to that, when we had through-hole components, most anomalies could be identified by visual means, whether by the naked eye or by some degree of magnification. But with surface mounting, with the advent of BGAs, obviously you couldn't see beneath the component. So a means needed to be devised to ensure proper termination and proper attachment to the substrate. Hence, a new subset of the industry was born.
I would add one more thing, which I should have said, is that the only difference between the X-rays used for electronics and in the hospital environment, and that's whether it's 2D laminography, which you might call 2.5D, or 3D or CT scans, all of which are used within the electronics industry, is that you have magnification and resolution improvements, which are substantially higher than you would get in the hospital setting, because the features we're looking for, especially today and moving forwards, are much, much smaller.
Right. And we're going to get into 2D and 3D for those of you who are watching or listening saying, what? How many Ds are there? We'll get into that. We're not going to let that comment slide. We're going to try and fill in the holes here. But we'll do that in just a little bit. I remember when BGAs first came on the scene, and I'm not sure if X-ray was used in our industry then, or if this was an alternate to X-ray. I think it was before X-ray was useful in our industry. There were these oblique angle viewers that would put, basically a mirror with a camera pointed at it, very close to the bottom of the board to try and look under the BGA. And they were extremely expensive pieces of optical equipment at the time. And I remember being able to play with one of those machines, and I just couldn't understand. It did look underneath it, but you can only see, the first 2 rows of balls under the BGA, and it was anyone's guess after that. It was a very fancy but rudimentary method of inspection under BGAs, and I've said this on the show before. Clearly X-ray technology causes voiding, because we didn't have voiding issues until we saw them on a screen. So shame on you guys. But Rob, what you mentioned something that caught my eye. You said that there were novelty applications in the early days of X-ray adoption within our industry, and then surface mount came along. What were some of the novelties relative to X-ray equipment? Were people using them just to count components on reels, or were they useful at all, really, in a major way in through-hole technology?
They were used as one advanced means of visual inspection. for looking at things like cracks in solder joints on leads, cracks on leads in through holes, any evidence of stress or deformation or cold joints in solder. But the science really hadn't been brought together with the technology into a body of knowledge or a body of work that could be applied on a systematic basis into the industry. It was really with surface mounting, introduced by the major manufacturers and the military, of course, aerospace applications, that X-ray, the necessity for X-ray came into its own. So we're talking late 70s, early 80s, particularly when surface mounting through large computer manufacturers such as IBM in those days, Compaq and so forth, needed a means of assuring that what was joined to the board really truly was joined. And we went from there. We went exponentially from there.
Let's get into, without actually getting into specific brands and things like that, X-ray, like many pieces of equipment in our industry, has a radical price range. I've seen prices that are shockingly low, and I've seen even more prices that are shockingly high. Give me an idea of, and our audience an idea of the general range from the low, not that you're recommending any of those ranges at this point, but what is the least amount someone can expect to pay for an X-ray equipment, whether or not it's useful, and what is the most someone can pay for X-ray equipment? And then we'll get into the details of what that money buys you, and how useful each end of that spectrum is.
Yeah, Mike.
We seem to have lost Keith again. I'm sure he'll be back, but in the meantime, let me switch to a more appropriate screen. And as soon as Keith comes back, we'll bring him back on screen. David, were you saying something? Yeah.
Yeah, there's a huge range in pricing, and what you're going to get out of it. Like you said, we sell refurbished systems. Put a new X-ray source in there as low as $25,000, but you're not going to get, what you get on a modern day machine. And you can get up to $1 million. Sure, you can go beyond that if you really want every single bell and whistle that's out there. So there is a huge range. You didn't want to get into too many specifics on it, but yeah, there's a lot of different image qualities, different features, automation, software tools. So we mentioned the 2D, 3D, all those kinds of things that are going to just wildly affect that number.
Let's try and make this a little bit more relevant to our audience.
Yes,
go ahead.
May
David.
I
Please.
offer? I said, as I agree with David. I would say if it's a new system, you're probably talking from a $50,000 upwards.
Yeah.
Okay.
And I would say for a 2D system, you're probably in the $50,000 to $250,000 range. If you're going for an inline system, my suggestion is probably $300,000 to $600,000 is my sort of suggestion. There are 3D CT only systems which are more in Robert's sort of world for sort of specialist applications, and they will be hundreds of thousands of dollars, that sort of side. So that's my take on it. But at the end of the day, like so much else in life, you pay for what you get. And as we hopefully discuss here, it's a question of what you want to do today, and also what you might want to do in the future. And I'm afraid that usually means you've got to spend more than you might want to consider in the initial. That's my observation. I don't know if Robert, from his experience, would say that was meaningful or otherwise.
Robert, as a consumer, how does that information play out in your world?
I would agree with David. There are CT systems in particular. The sky is really the limit, depending on the need and the application. You start on the low end at 250 to 300, and you can go easily in excess of $1 million, and in some cases multi-millions of dollars with very unique applications. I mean, CT scanning systems are used, for example, to look at jet engines on airplanes now, and these are custom-built, bespoke systems that sit in very large vaults in very large manufacturing facilities, and They have one application only, and they've been designed specifically for that. But in our industry, in electronics manufacturing, most of what we do, X-ray systems fall into the 50 to 300 category that both Davids have already described.
So for average mere mortal assemblers within our industry, electronic assembly, 50 to 300,000 is basic bookmarks. I know you can go up to 1 million. I know you can get some refurbished stuff for maybe half of that. But it 50 to 300 is, if I went to my boss and said it's low 50, high 300, I'll probably hit that mark.
I would say, and again, no disrespect to any manufacturer, and the less expensive machines may be adequate for your immediate need, but you're probably talking from 100,000 upwards is right. Maybe if it's your first ever machine, you're probably looking in that sort of region as a probably more sensible approach, so you don't undersell your boss.
Right. Yeah,
in terms of what money you want.
One of the David brings up a good point is that if you don't know yet, because you don't have one yet, 100,000 is definitely a good starting point.
Okay.
And we've had customers who come to us and say, "Hey, we're just starting BJs. I just need to see if the balls are there." Right? It's like, and to David's point, hey, that we can get you something for cheap to do that today, but what about tomorrow? Right? What are you planning to do?
Yeah, I always there's two ways to measure equipment's life. One is how well is it built? How reliable is it? How long will it continue working? Right, that's one thing. And the other is how long is it relevant? And I know in the cleaning world, which is the world I come from, that's a huge issue. We have machines that we built in 1992 that are still running, surprisingly. They're 30 years old and they're still technically they're running, but I don't think you can clean anything modern in it today. So they're not useful, whether or not they're working. And how much of that is true in the X-ray industry? How quick is the evolution, the evolutionary progress of X-ray machines? Is it like the early days of computers where, 6 months after you buy it, it's now being replaced by something half the price and twice as fast? Or has that evolutionary stage kind of stabilized and slowed down a little bit?
I would say the X-ray machines continue to work almost indefinitely, as long as you haven't gone in and sort of compromised the radiation safety environment. But it is a question of the magnification and resolution. I would say 20 years ago, there was a change from the type of X-ray tube that was used that allowed substantially better resolution and magnification. And in the last 10 years, you've had a great improvement in the type of detector that is used to present the image to the screen. So the technology has moved, but in terms of the functionality, 20 years ago, you could have got a much more expensive machine that would still see the things that you could probably want to see today. But it's much easier, and the price has come down because the detectors are less expensive. This is what is called flat panel detectors as opposed to image intensifiers. And the tube types, and I think that's really the differential in terms of pricing, and I know we may come on to this later, is that does the X-ray system have what's called a closed style X-ray tube, or does it have what's called an open style or sealed transmissive style X-ray tube? And that really does define not just the resolution the machine can see, but actually most importantly for the electronics and things getting smaller is the magnification it can achieve.
Excellent. Let's get into some of the extremes. We have extreme prices. We have 25,000 to $1 million, which was quoted. Now I realize that each of those examples are extreme examples. One's a refurbished machine with not a lot of capability. One is probably something quite custom and super fast with every bell and whistle. Probably neither are appropriate for the masses, right? For the everyday user. But generally speaking, if we can stereotype, we'll call them the low-end machines and the high-end machines. I don't mean they're bad machines. They're just, low-featured machines, cost-centric, and fully featured machines, where cost is no object. What can some of those machines do or not do? So if I'm looking for value, if I'm looking for price Price and value, two different things. If I'm looking for price, what basic features am I going to get, and what features that you think are important to the average assembler that they're not going to get? And then I'll ask the same about the higher end machines. If I'm an average assembler wanting to inspect under QFNs or BGAs, or the average typical application, where should I stop spending? At what point are features just more money and not a lot of value? So let's start with the low end. What am I not going to get that I probably should want if I just concentrate on price?
I want to not disagree with your question. I understand the premise, but in the X-ray world, being a bit of a weird world, it's a little bit difficult to describe it in those sorts of things.
Okay, fair enough.
Mentioned magnification. In the case of ball grid arrays, you don't just want to look from the top down. You need to be able to look at an oblique angled view to try and look at the interfaces between where the BGA ball solders to the board and to the device. And if you look at it in the top down, the bulk of the solder in the ball will obscure what you're trying to see. So an oblique angled view is important to be able to subtly distinguish if there is a problem. And achieving that within an X-ray machine can be done either by tilting the sample relative to the tube and detector axis, or you can keep the board close to the X-ray tube and tilt the detector. Forgive me for being a little bit technical, but in the first way, you lose magnification. In the second way, you maintain magnification. And ultimately, what you need to do is all of the X-ray machines are giving you an image. If the blob you're trying to see as a BGA or a QFN joint only covers 3 or 4 pixels, is that good enough in terms of magnification for you to make a judgment whether it's good or bad? If it covers 20, 50, 100 pixels, that in theory gives you more information to be able to compare and contrast with other examples. And that's where magnification becomes important. And I suggest the lack and presence of magnification arguably differentiates how much you're paying at a very basic, at a simple level. I don't know what my fellow panelists would comment on that.
David, as a manufacturer of equipment, does that ring true?
Yeah, I think you put it really well. When you're looking at a QFN, right, something like that, you top down's typically fine. You're looking at voiding on that main center ground pad to make sure heat's being transferred through, that kind of thing. VGAs are a mean component. Design engineers have loved them because they can save space. Manufacturing engineers I've only heard hate towards them, right? They're a complicated little beast, especially as they get smaller. So being able to get that level of magnification is critical. Now, what you're building also comes into play, right? So if someone is building a board that's going to go into a satellite, you better get that right? You really had better make sure that everything on there is working, is doing well, inspecting every ball on there. Obviously, other inspection types along the way before and after X-ray are critical as well. If you're building a consumer electronics, mass-producing TVs or something, doing a simple quick check is probably all they're going to do, at least on the production line. Might do some failure analysis. So there is a lot of different nuances that go into this sort of thing, right? What is the need of the general person who's going to be doing this is really hard. What are you building, right? How fast are you building it? How critical is it? Again, if it's going into a pacemaker, hey, if I'm getting a pacemaker, I want to know that thing was inspected thoroughly, right? As thoroughly as possible. I can tell the remote for my TV is not, right? Not the high quality.
Right.
They don't have nearly the inspection points. They're not going to be spending the money on that.
Cost of failure is way different between a TV remote and a defibrillator, right?
Exactly.
I think another very important consideration is presence of the BGA versus the long-term reliability of the BGA. And what I mean by that is it's one thing to take a picture of the BGA and verify it's in the right place, the balls are in the right place, pattern recognition, all the balls are circumferentially speaking relatively uniform, versus something like a head and pillow defect or a micro crack, which is fiendishly difficult to detect in some applications.
Yeah.
And depending on what is needed, depending on the data required, depending on the degree of reliability demanded in the product and the application, will in many respects drive the type of X-ray system that is suitable for that application. So as Dr. David was saying, often you need an oblique view looking at some of these locations because they're very, very difficult to spot. Certainly from a top-down view, they're almost impossible to spot most of the time.
Right.
And I would also add is that with generally price is that your listeners may be surprised, but a lot of people will expect today that there's a fully automated solution. You put all your boards at one end in a hopper, you press a button, go away, have your coffee, and come back and everything's tested. Well, I'm sorry if that was true. All of the manual offline X-ray machines that have been sold and continue to be sold wouldn't have been sold over the last 20 or 30 years. There is an automated solution for the right application. And that's something that the good supplier will need to discuss with it, because as you get to automation and also the 3D, you have to take multiple pictures. And then because you're taking multiple pictures, it takes more time. And this is what people don't want in a manufacturing process, time. So you sacrifice time, which gives you a poorer image, because unfortunately everybody has an expectation of these video cameras for optical stuff where it's fantastic quality. But if the X-ray takes a finite time to fog the film, to use the old-fashioned language, to capture on the detector, and you speed up the throughput, you reduce the quality of the image, and therefore the analysis, automatic or otherwise, becomes poorer. And then you have the complement to your escape, which is the false call, stuff that looks wrong but isn't, and you're back to retesting everything.
Yeah, that makes a lot of sense. We talked about, Dr. David, you talked about 2D, 3D, and I said let's hold that thought a little bit. Let's use this time briefly to get into the major differences in the technologies. I know there's different types of tubes or detectors, however they're referred to. They probably have different attributes, and I know that there's 2D and 3D. That's at least two of the major differentiators between specific machines. Tell me the difference between 2D and 3D, and in what application would one waste money, maybe a narrow application where one might waste money getting 3D when 2D is all that's required, and in what applications would be would be missed out if they only had 2D?
Well, what I would say is that for a typical board shop, which is perhaps different from Robert's thing where he's doing failure analysis, you're going to require as a minimum a 2D inspection, a simple image, same as the broken leg in the hospital you alluded to earlier. But we also need the oblique angled view and being able to have the magnification and not lose that magnification at an angled view. Now, you said 2D and 3D, I'll come on to that, but there is this so-called 2.5D or laminography as it's known in the industry. And this is using a, forgive the language, tomographic, a CT technique, a CAT scan technique to generate layers within the board. So you can begin to separate, say, side 1 from side 2 at different layers. Now, this takes more time, is more expensive as usually an add-on to these 2D systems, but potentially for LGAs that are overlapped or QFNs that are overlapped side 1 and side 2, you may not know where the voiding is. Is it at the die level? Is it at the substrate level? And whether it's side 1 or side 2. And the potential, although I would say it's a nice to have, not absolutely necessary to have, would be within a board shop to actually go and have that functionality as an additional extra. When it comes to tomography, CT, CAT scans, then they can be added again as an option to some 2D systems. But for the people who are doing it for investigations and specialist applications, then they tend to be standalone systems for technical reasons that allow high precision movement of the sample and multiple images. But you're talking, rather than seconds to capture an image, you may be taking minutes or hours to actually achieve it. And you're looking at a model, and that's where the non-destructive testing for castings and things like that uses it all the time. So that's my take on it. So 2D, maybe laminography. Probably for most board shops, not CT. Go to a supplier who could provide that, probably, until or unless you're doing it so often you have to take that functionality yourself.
Anything to add? And welcome back, Keith, for those people who are watching on YouTube. We actually have 5 guests. We have Keith and his dog, who is desperately trying to get into the picture. What's your dog's name, Keith?
Duke. Yeah, he's
Duke.
Definitely trying to, and I'm trying to.
I see you moving your camera, trying to get him out of the picture. He's totally welcome on Reliability Matters. We're a dog-friendly show here.
Yeah, but no, to add a little bit more to what David has said, with IPC 7095, which looks at, or at least gives specs or numbers which are acceptable for joints on an interface, it's very hard to make those measurements unless you have laminography. Simply because an angled 2D view, if you move it around a bit, you can actually work out which, if we're talking BGAs, whether the voids are at the top or the bottom interface. But what you can't do is an automated void calculation, because effectively you're looking at an angle. So laminography is crucial if you're working to that kind of a spec. And my own personal opinion is laminography really in this day and age is needed, especially when we're looking at thermal planes on components where you've got densely packed double-sided boards, and the customer has given you a spec that this thermal plane has to be at a minimum of 20% voiding. Because if the voids are any bigger, then you don't have the heat transfer. And if you don't have the heat transfer, the component overheats and the die cracks. So, laminography is becoming a bigger deal for people.
So the so-called 2.5D is, it sounds like that's kind of the floor. That's kind of the basic starting point that one should consider rather than strict 2D.
The unfortunate part about the 2.5D situation is it's often portrayed by certain marketing types as true 3D, which it is not. And 3D is CT scanning, pure and simple, period, full stop. To Dr. David's point earlier, CT is expensive because it's time consuming. True CT, some of our more complex applications on things like additive manufactured parts or castings or things of that nature, we often put the part in the machine at 5 p.m. or 6 p.m., set it up, hit start, and go home. And we come in the morning, 8 to 10 hours later, and we have several terabytes worth of images ready for post-processing. That's what it takes. And it's available for those who wish to pay for it, but it is an expensive process because of that.
Hence the 25,000 to $1 million, as we started off this conversation with. There's a lot of stuff put into machines that vary
the particular description that I just gave you in a generic form, we perform on $1 million system, and that system can take a BGA ball and divide it up into 6,400 discrete slices. So if you like that level of precision, we can provide it.
Wow, that's a good explanation of $1 million machine. Yeah,
and pay for it. You'll get a large bill at the end.
And in terms of the the premise of this particular podcast is that I would suggest a good supplier will understand what you, the user, wanted to do, and should be honest saying is CT is not for you. In the vast majority of cases, particularly from a board shop, it isn't. So again, it's educating the user to understand, like a fully automated system, I'm sorry, even if it exists, it's not for you. And to say where X-ray can be used, and also to remember X-ray is not the only game in town. It's a complementary technique to all the other tests you're putting in.
Sure. And that was a perfect segue, Dr. David, to my next question, which is what questions should a responsible equipment supplier be asking a potential customer? And then I'm going to invert that. I'm going to say what responsible customer should, what questions should a responsible customer ask of their X-ray supplier? But let's start with the supplier first. What questions are helpful for the supplier to know to even ask the more questions and guide the customer toward a suitable solution?
I always start with questions about what are they trying to accomplish, right? What kind of homework have they done already? But a big part of it is, are you a high mix, low volume house? Are you a low mix, high volume house? Those are huge factors in what kind of machines you want, right? If you're doing high mix, changeover on and programming a lot of different things can be a big headache. So you want a more flexible, probably a more manual machine. But again, I'm kind of jumping to conclusions here. But those are definitely big factors. What kind of stuff you're making? We already talked about the matter of reliability. How much reliability in your product you need? Obviously, budget is important, but as we discussed, with that huge range of possibilities, what budget somebody might initially set aside for something could very well change depending on where things go. So it's always an exploratory conversation. What do you need? What do you think you need? And to Dr. David's point, I can't tell you how many times people have come to me and said, I need CT. This is great. It's super easy, right? It's really cheap these days, right? And well, yeah, it's cheaper and easier than it used to be. But if you want the level of detail that Rob can provide, go to Rob, right? He'll do that for you when you need it. If you need it on every board you're making, then I really don't know why. Unless you are making satellite boards and that's it, a couple of years or something.
That's a good point.
But,
we're assuming
there are cases for nearly everything, right?
We're assuming people are buying X-ray machines. Maybe they're just simply renting the technology through a contractor like Rob that specializes in failure analysis and other things. That's a good point. What questions? I'm a potential buyer. I think I need X-ray. I don't know much about X-ray, which is probably a typical customer. And I'm not slamming the customer. There's no dissing at all. It's just, why should I know, right? That's not my business. Where do I start as a consumer? When I say who do I call, I don't mean what specific company, but what types of questions should I be asking? How do I vet the answers? How do I vet the company? Is it made in the country where I'm going to use it? Is it made somewhere else? Support, all those things, quality, all of those things, features, of course. How do I go about starting the process of proper vetting for my application and for the suitability of that company to provide what I actually need?
Well, I guess the short answer is join the SMTA and talk to some other users.
Excellent. I'm glad you brought that in.
Unfortunately, sales guys have a habit of not telling the truth. If we go back to the CT issue, a long time ago, I had a company who bought a machine from someone else, and they believed they could CT a whole board rather than they just had to cut out the small piece they wanted and basically destroy the board before they could use CT. And the guy that sold them the machine hadn't actually told them that. So yeah, it can be a nightmare. But yes, if you can get independent verification from other users who are doing something similar to what you're doing, then that's the good starting point. But then you need to decide, what am I going to be X-raying? First question, do I need a system which is inline? Do I need a system in the lab? Or do I need a system that will sit beside the production line? How many people are going to be using it? What's the skill level of those people? Because that's going to define how easy the machine is to use. And a whole load of internal questions. But the biggest one is, for the next 2 or 3 years, what am I going to need this machine for? And I think once you have the answer to that, then you're moving in the right direction.
I'd
Right.
also add that it's worth a consideration of attending one of the major trade shows in your location, because most X-ray manufacturers will be present and have machines that are able to work. So, and most importantly, bring your samples to have a go and try some, because then you've got some pictures not only about what this whole range of possible equipment has, but also, and more importantly, you begin to build up your own training manual of what is good and what is bad. And I know we may discuss this about what the heck are we seeing in an X-ray image. Ultimately, experience. The radiologist in the hospital is a radiologist because they've seen more X-ray pictures of your insides than you have. And I'm afraid experience is key. Robert is the man he is because he's seen a heck of a lot more X-ray images than I have, and this is part of how you do it. And if you build that up, this allows you to do a training regime of what is good and what is bad of what you are doing, not the nice example the salesman and the demo guy at the show has in front of them.
Right. Rob, what was
Yeah,
you're a consumer of equipment. You had to go through the process of vetting a supplier and analyzing their capabilities with your needs. What would you recommend to a purchaser of X-ray equipment based on your purchasing experience?
Well, we're a little bit different, Mike, in the sense that we're a laboratory environment. And so much of what we do is one-off projects. We'll get a single board or a handful of boards that have unique problems. And quite often, somebody else had an X-ray system of a lower power or resolution or magnification than ours, and they still can't find the defect. Yet applying power to the board proves the defect is there, and then we come in as a third party to offer a second opinion and find it. So our questions are much more detailed than the ordinary contract manufacturer, in the sense that we want to know every feature, hardware and software in the system, how we can use it, ease of use, trainability, and whether it applies to the specific applications that we're doing. We're actually one of those rare birds who use all of the features in the system as it is presented, and the advanced features as well. We take advanced training. We're very serious about that because that's what people pay us to do. You flip that back to the customer, we use that knowledge to educate the customer, just as you do in the cleaning business. We do the same thing in the imaging business, in that we screen out things on the front end to ascertain what the proper system application is to the requirement. For example, I had a customer come to me once who had 42 boards, each with 36 BGAs on. And they actually asked me if I would CT each and every BGA on each and every board. So I did a mathematical exercise out of that and tallied up the hours required to do that. And if we actually did that project, it would have put several of my employees' kids through college and their grandchildren in perpetuity. So to simplify things, we said, rather than do 42 boards, let's do 2 boards. And let's select certain BGAs on each board. We'll do the full analysis there. Instead of spending $80,000, you'll spend $4,000. And in the end, you'll have some indication of the reliability of the lot. And if the results are favorable, we can stop there. If the results are somewhat questionable, we can huddle again and determine, do we go further? But you have to take customers along in steps. You can't just take their money and present them with the huge bill later because you've ruined your reputation by doing that, and they'll never talk to you again. And they'll badmouth the industry and the technology based on a single bad experience. So education is vitally important. I spend probably 40% of my time just educating customers for the reasons given.
You talked about the advanced training and the training in general that you receive to be able to use this type of equipment. I know in your case, Rob, you have a machine where you use every single feature that it's capable of providing because you're a contract shop. You're saying yes to a lot of different applications,
Right.
which a typical OEM might not need. But what can a customer expect in terms of the training required? I look at some radiology images online, and I don't know what I'm looking at. Remember those images you'd see? That they show you a picture of just static, and you're supposed to interpret what you see out of that. I can never see anything in those images. And radiologists, as you mentioned, Rob, they just see, or Dr. David, I forget who said it, thousands and thousands of images, and they can, they're fine tuned to that. If I purchase an X-ray machine to look at head and pillow defects or cracked BGAs or voiding under a QFN, whatever the application is, can I just look at the image and go, oh, there it is, or do I have to go for training to interpret the image, or is there computerized interpretations, renderings that will, put a red box around a defect and show me where to look? How much out of the box plug and play are these machines, and can any person with 20/20 vision or so automatically spot a defect? Does that question make sense?
Yeah, most systems are pretty easy to use. The basic training doesn't take any time at all. You can be, on most systems in my experience, once you've gone through the basic training, you can actually be inspecting boards within an hour or two, if not sooner. The problem comes once you have the images, what do you do with them? And that's a function of the skill level of the operator or the person's working with the operator. Keith Bryant already cited a very, very good source, which is IPC 7095, which provides all kinds of examples of surface mount defects, and specifically BGA related defects, and many of their root causes. But whether individual operators or individual companies actually have that knowledge, it varies from site to site.
Right.
I'd like to add that in the electronics world, my experience is everybody blames the BGA when it doesn't necessarily mean it is the BGA.
Very
Now,
good point.
from the pro side, without an X-ray, how do you know? And that's a good salesman's argument. But from a practical point of view, because everybody blames the BGA, most people don't check the other end of the connection, and often a failure may be at the input-output connector rather than the BGA. But trust me, and it's paid my mortgage, I'm not going to hide from that, everybody blames the BGA. So it's being smart to understand it, and it goes back to having good, what I would call good and good bad examples of what you're looking at, so you can build up that training matrix as people see more, learn more, and become more experienced. If you're trying to look at 400 300 micron diameter balls, they all look very similar to the human eye. Even with the AI revolution that's going on, if you're trying to see that through multi-level, multi-sided boards with things overlapping and all stuff like that, it's not easy. So I would say the machines are very easy to use. Understanding, you could say, is a lifetime, but it is a question of looking about what's practical, what's sensible. If you see voiding, you know what voiding is. And if it's big, you don't necessarily need to know how big it is. If you can see it, it's probably too big. So the idea is measurement can be important if that's what your customer requires, but it's understanding how to be practical and time effective. And so training people so people who don't cost less can do it to your level.
we're running out of time, so I want to wrap up with a couple more questions quickly. In the consumer world, I think there's no product with more safety warnings on it than a ladder. If you look at a ladder, it's filled with warnings and things like that. And my understanding is that the cost of a ladder, about 20 to 30% of the actual cost of the ladder is insurance, right? Because people fall off ladders and do crazy things on ladders and then sue the ladder companies. So there's a lot of CYA going on with ladder manufacturers. I'm not sure if X-ray is just as bad, but I know when I go to the dentist and just get my, annual X-ray of my teeth, here comes the lead cloth, right? And they cover all the important bits, with a thick lead cloth to make sure I'm not getting radiation poisoning. And I know in certain industries, particularly, nuclear industries and things like that, people are wearing badges that are sensitive to detecting radiation. X-ray uses some form of radiation. How much should I pay attention to the safety concerns? Can X-ray equipment be used anywhere? Are there permits required? Are there specific safety protocols that have to be followed, or is it all just built into the machine and the customer is, relatively unaware of the dangers and how they are protected from those dangers?
My point, the question is a very good one and a very simple question, to which the answer is bloody complicated, if you pardon my things. Because X-rays are ionizing radiation, which means they are covered by statute law, as are hospitals, nuclear stations, and other users of radiation. Unfortunately, from a manufacturer's point of view, is every country has different statute law for essentially the same thing, and the requirements and regulations may be different. And in the US, I believe different states have different regulations as well as federal regulations. And so the whole thing is, the machines are incredibly safe. That's the take-home message. But the regulations and requirements vary from very onerous to you just have to fill in a tick box, and it really does depend where you are. And that's where a good manufacturer, a supplier, should be able to help the customer if it's new. I mean, companies themselves have their own regulations as well that do this. So it's not necessarily complicated, because the X-rays are, to all intensive purposes, there's not an issue, but it has to comply with the relevant regulations. I'm sure David has to go through this on a regular basis.
Yeah, that's Dr. David hit it on the head. These are safe. These are cabinets. They do not emit radiation outside of their lining, right? There is shielding on these cabinets to make them safe. We get these questions all the time. Our techs have been to places where people are wearing the lead aprons. You're like, why are you doing this? Right? So education and what's going on. Someone came and sold them on the need for all this safety equipment. It's entirely unnecessary. But each state in the USA has its own set of rules. Each country outside of the US has its own rules. And so you really have to make sure that you know what's going on in your particular area. And yes, your vendor should be able to help you with that process at a very minimum, point you in the right direction. Hey, go read, you'll find the regulations in your area here. But yeah, some places are just, you register it with where you are and they know you have it and you're good to go. Some places are, well, you need to do this. You need to check that. You do have to wear a dosimeter. Some companies have their own regulations, so they do extra checks just to be extra careful. But
are there any geographic
safe.
locations where it's just not worth getting because there's too many boxes to check, or is it just a question of one check marks or 10 check marks? Is it?
Yeah. Different countries have different rules. I mean, in the days when we put machines into exhibitions in Germany, each machine was checked by an independent guy from the Tuft, and he came and had a dosimeter, and he checked all the way around the outside of every X-ray machine, even that was just set up to be working for the exhibition, and you got a little sticker you put on the front of your machine. So, those guys are quite tough. In some areas, you have to register it with the Radiological Protection Board, and you have to have a nominated person who goes on a course. But, it's all documented. The people who are supplying your machine should be able to tell you. But both Davids have said, the machine inherently is safe. It's lined with lead. It's got interlocks so that you can't open a door with the tube on, and a whole load of other great things. So essentially, it is a safe machine. But because it's a radiation source, it has to be characterized as the same as the stuff in hospitals, the stuff in your dentists, and everything else. But that's
Right.
basically because of the radiation, not the machines.
Right. No, that makes
And
sense.
it can, and you as the patient in the dentist, you're only there for one X-ray a year. The dentist or the radiologist is doing them all day, every day.
Right.
So therefore, it's protecting it. And in terms of the safety cabinet that all these X-ray systems have, it means that the operators can be there 24/7 if they really were made to do so, but full time without exceeding any safety thresholds that might exist.
Our industry, and every industry, every consumer product, I think every product made, is plagued by cheap imported knockoffs. People trying to make a buck or two by providing the very, very least level of a product. Does that occur in the X-ray industry? And since we're on the subject of safety, if someone is able to score a deal on a new, and I'll call it, the cheap imported knockoff machines, we all have, as I said, we all have those in our industry. We certainly do. Is that a concern for safety, or is it just a concern for, other aspects of quality or features, or do these lower priced knockoff type machines still provide some degree of value? David, you deal with this every day, and I know you're hesitant to answer that question, but
I'd say is that in the electronics industry, there are a lot of machines from various different countries, and you have to take some view that most people want their people to be safe on what they use. So I would hope not, and I would suggest, price should not ever compromise on safety, and I hope and believe that is the case. But if you see a machine where somebody can open the door with the X-rays are on, or they can tamper with it, then you don't want to go anywhere near it.
Right.
And I understand that, but I've not seen any machines, but you can't. It's more a question of somebody comes into your lab, stands on it and drills a hole to put the safety notice in that goes straight through the radiation shielding. That's when you have the problem, rather than the quality of the machine itself.
Stupid human tricks. Yes, we've all seen that. Last question, because we're completely out of time. I just kind of want to do a round robin. Any further comments on or advice that you would give a purchaser or a potential purchaser of X-ray equipment that maybe we haven't covered? Let's start with Keith.
Well, it's all the basics. Decide what you want. Decide how much budget you have and try and spend as much as you possibly can. Buy something which is a bit future-proof. If your components are getting smaller or you need more resolution or whatever, don't buy something that just works for today. Buy something that's future-proof. And as I said right at the beginning, talk to people who are using that kind of equipment already, maybe even from that manufacturer. And basically, get as much ammunition as you can before you make the decision.
Excellent. Dr. David?
I'd agree with everything Keith says. I would also say is don't use the basis of optical inspection as the yardstick for X-ray inspection, because the images are different because of the technology. So having a understanding that is a separate and complementary technique, and the way it works is different, and contact different manufacturers, try them. They're all willing to do samples, and so educate yourself by talking to them as well as existing users in order to know the questions to ask and go back to, because why should you know those questions to ask the first time you go and talk to somebody?
Excellent. David?
Yeah, I think test driving machines is huge. Doing your research as you can. Don't be afraid to call, right? Call multiple vendors. Ask your questions, and how helpful and informative they are is a good learning lesson on do you want to deal with this company or not, right? And then, test drive it. Send if you can't do anything else, at least send the same sample to everybody you want with specific instructions on what you want to see so you can compare apples to apples. But better yet, go visit, get in front of machines. Trade shows are a great place to do that. Here in Southern California, there are several different manufacturers with demo rooms not too far away. And it's just a nice place to visit. But definitely try things out and have open, honest conversations with the different vendors and learn everything you can, right? Because everyone's situation is very different.
I like what you said about
needs are different.
Gauge the responsiveness as you talk to the potential vendors. The best responses you'll ever get are in the sales process. If your sales process experience is not pleasant, I can't imagine what service would look like, right? That's kind of the top. It's downhill from there. At worst, it's downhill from there. At best, it's the same. Rob, as the only person on this screen that has purchased equipment, not made it or designed it, tell me what advice you would give that we haven't covered, or reinforce some that we have.
I would agree with everything that's been said previously. I would add 2 more points. One, service. What is the degree of service, hardware, software, and field service support from the provider you're interested in? And secondly, and this is my little idiosyncratic question, I always ask this of every piece of equipment that I'm going to buy: what is the first thing to break? And I'm interested in that for 2 reasons. Number 1, I want to know. Number 2, I want to see how the salesperson handles the question. If they're evasive, that's an indicator. If they're direct, that's an indicator too, usually a favorable indicator. And I make note of that.
Excellent. Well, the secret mind of Robert Boguski's purchasing habits. That's a great question. I find myself, when I purchase equipment, because I own a factory, we purchase equipment. I don't judge a vendor by if they tell me these things never break. I don't put a lot of faith in that. I put a lot of faith in what happens when it does break, because everything breaks at some point. And I'm not interested in a company with 0 failures, because I don't believe it. And if it is true, then they don't have any experience when the first failure comes. I like when we provide references to customers upon request, we will intentionally provide a reference of someone who has had an issue. And we do that so that the customer can get an idea of, we're not perfect. We think we're really good, but we're not perfect. Nothing's perfect. And we want them to know that what happens when the imperfect science of building equipment fails you, where are we? That's where I think any manufacturer, earns a customer's business, is by partnering with the customer in good times and in bad, and, making sure that they understand the problem, they fix it, and make sure it doesn't happen again. And to me, that's more important than the promise of something never failing. I don't want to put it to the test every day, but I certainly think that's a great question to ask, Rob. Well,
I would just like to say one more thing. I agree entirely with what you said, but I would also say is that let's be realistic. If all the boards made were perfect, no test and inspection equipment would ever be required. But I would say that the good companies invest in that level of equipment because they know exactly for the reasons you've just said, because how do you know? And do you want to know rather than does you want your customer to know first?
Yeah, all great points. Well, you've educated me, and I hope also our audience feels equally, if not more, educated than my experience. So thank you, Keith Bryant and Dr. David Bernard and David number 2. By the way, I should mention, and we didn't mention this at the beginning, you're with Creative Electron, and Robert Boguski with Daytest. Thank you all very much. Keith, you have a consultancy. Is it Keith Bryant Consultancy? Is that the name of the company? And Dr. David, you are also a consultant as well. Do you operate under a specific name?
Sadly, but unoriginally, David Bernard Consultancy.
All right. Well, I that's nothing sad about it. I like to be direct, and there's no ambiguity. We know who you are and what you do. Thank you for sharing your years of experience in the X-ray world. Thank you for educating me and my audience on techniques and tips and tricks for evaluating X-ray equipment and companies, and providing that valuable bit of education. I really appreciate you guys being here. Thanks for coming back. All of you have been on my show in the past, so you're all repeat performers. Actually, David, I think Dr. David has been on the show. David, I don't think you've been on the show. I know the owner of your company has. Right. So welcome to Reliability Matters to you, David.
Thank you.
Welcome back, Keith and Dr. David and Robert. I appreciate you guys being here. So thanks again. It's been, we're a little over time. I apologize to my audience for the extended length of this, but hopefully you found that worthwhile. So I'll see my audience again in a couple of weeks, and thanks again, fellas, for joining me.
Yeah, thanks,
Thank you, Mike.
Great to be here.
Good night.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, and on our newest channel, Amazon Music, or virtually wherever you get your podcasts. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks for your questions and episode suggestions. Please keep them coming. Send comments to Mike at mikeconrad.com. That's Conrad spelled with a K. Once again, thanks for listening or watching. If you're watching this on YouTube, be sure and click the subscribe button and the bell icon to be notified when new episodes are released. I'll see you again in a couple of weeks. In the meantime, stay safe, stay healthy, stay happy, and of course, keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.